Go.
Welcome to permanent remediation for Onondaga Lake sediment, with additional material on supplemental sediment consolidation area waste bed 13, human risk assessment. This material has been assembled and will be presented by the Camillus Community Coalition. First, before we get into the main sections of the talk, we want to go over risk. Risk is something that's common to everything we do. It can be broken down into three components: severity, occurrence, and detectability. With regards to the Onondaga Lake cleanup, severity typically refers to the toxicity of the chemicals that are being cleaned up. Occurrence refers to the exposure potential of these chemicals to humans and the environment. And detectability has to do with our ability to detect these materials and do something with them before they cause bad effects to people and the environment. Overall, risk occurs for the Onondaga Lake bottom remediation project when high severity occurs, that's high toxicity, is mixed with a high occurrence or exposure potential, meaning that there's a lot of likelihood that this will come in contact with humans or the environment. And we have low detectability, inability to detect the material before it causes harm. This presentation is going to be broken up into two main sections. The first section, we're going to focus on short-term risk. In the short term, meaning the next 7 years, the human health risk assessment that was done by the EPA for the sediment consolidation area waste bed 13 addressed only severity and occurrence for geotube operations. It didn't address the detectability of volatile organic compounds throughout sediment consolidation area operations. Overall, there's a lack of sufficient accuracy and sensitivity of current volatile organic compound detectors around the waste bed, and the risk that has created a cancer and non-cancer issues it will create cancer and non-cancer risks for the surrounding community, and this happens to be equivalent to the risk that's present right now in the lake from eating fish. In the long term, in the second half of the presentation, we'll talk about the overall approach to the remediation project and how the exposure potential has been taken care of by encapsulating the waste, and there is going to be monitoring and long-term maintenance of the waste beds. Unfortunately, in the long run, nothing's being done about the toxicity. The toxicity of the sediment will remain the same as it is in the lake once it gets up to the waste bed and is encapsulated. The overall remediation of Onondaga Lake bottom sediment does nothing to reduce this toxicity or its contribution to risk, and we're going to present some information on permanent remediation that can be used to supplement this project and overall dramatically reduce the risk for Onondaga Lake area in the long run. Our first section, presentation, is looking again at short-term risk, and we're going to talk about levels of volatile organic risk, compound risk during the pre-dredging activities that are going to go on the next 2 years around the waste bed. In 2000, Department of Environmental Conservation was required to register waste beds 9 through 15, and when they did that, they found that in these waste beds there's already organic chemicals, volatile organic chemicals, benzene, chlorobenzene, and dichlorobenzene. This document dated in 2000 gives some detail on those components and what's there. Currently, the DEC and Honeywell have put together plans for the next 2 years to prepare the waste bed area, waste bed 13, for receiving sediment from the lake. As you can see here by the map, there's a blue line that defines a work zone perimeter. The dark blue dots around the perimeter are 8 photoionization detectors stations along with dust monitors that have been put in operation as of July 24th. These are to monitor, the photoionization detectors are to monitor volatile organic compounds in the air for the next 2 years while they're preparing this site for receiving the sediment. This is all spelled out in a document that was released in June from Honeywell regarding the Community Health and Safety Plan, and in that plan, the Department of Health has set notification and action levels for volatile organics picked up by these sensors at 2 parts per million and 5 parts per million. The photoionization detector that's being used is called a 2020 Combo Pro, and we're going to assume that it's maintained and calibrated properly. In that case, it has an accuracy of plus or minus 2 parts per million at detection levels less than 20 parts per million, which is where we're interested in for this activity. The detector also has a lower detection limit for benzene, chlorobenzene, and dichlorobenzene of 50 parts per billion. This is the lowest level that the detector can sense at. Any chemicals present at lower levels than that, the detector won't see. The issue here with the detector is, remember, the Department of Health has set notification and action levels at 2 and 5 parts per million, as indicated on this graph by the dotted lines. And accuracy, or plus or minus 2 parts per million for the detector, is indicated by the window around each of those detection levels. The problem we see here is that at 2 parts per million, the level at which something will start being done about issues developing from that level of toxic chemicals in the air, the sensor may not read anything. Its accuracy around that 2 parts per million is anywhere from 0 to 4 parts per million for a reading. This is definitely a problem and shows that the sensor is not accurate enough to monitor at the levels that the Department of Health has set. Now we're going to focus in a little bit on the HHRA results, the Human Health Risk Assessment for the waste bed. The HHRA defined acceptable cancer and non-cancer additive risks for the area. The cancer additive risk can be anywhere from 1 in a million to 1 in 10,000. The acceptable additive risk for non-cancer is less than 1 in what's called a hazard quotient. The hazard quotient is at 1, says that there is no evidence that the EPA or the DEC can find in literature where people exposed to levels 1 or below have had any issues with any health effects at that level. Above 1, there is literature and evidence that people do have health effects with regards to inhalation of these chemicals. Overall, the Human Health Risk Assessment found that the dredging operations in the sediment consolidation area is overall safe, and the levels that they used up at those sensors to establish that it will be safe are found here in this table. You'll note these levels are fairly small, starting with benzene at actually 600 parts per trillion, chlorobenzene 20 parts per billion, and etc. At those levels, at the sensors they currently have around the waste bed, the cancer risk to the community for benzene from inhalation of these volatile organics is 1 in 4.3 million. Dichlorobenzene, 1 in 4.4 million. The hazard quotients are all less than 1. So again, the HHRA said that over a 5-year dredging activity and putting material into the waste bed, which is 1,825 days, the community exposure to volatile organics at these levels is safe. The problem here is that at these levels, remember the sensor, the 2020 Combo Pro, it can only detect down to 50 parts per billion. You'll notice that the levels the EPA used to determine that the communities would be safe for benzene, dichlorobenzene, and chlorobenzene fall well below the detectable limit of this sensor. What we're going to do here now is we're going to look at how much risk is introduced to the community by the ability for this sensor to detect volatile organic compounds. So using the Human Health Risk Assessment results and then doing scaling, we can actually figure that out for the next 2 years before they actually start dredging sediment. So again, as we pointed out, the sensor is not accurate or sensitive enough for geotube operations, but how much will it protect the community over the next 2 years before the geotube operations begin? Our assumptions are that in the next 2 years, Honeywell's operations will be going from August to November 2010, April to November 2011, and April to May of 2012. This is equivalent to about 251 working days. What we want to do is determine, given that the levels of volatile organics could be as high as 50 parts per billion, 2 parts per billion, or 5 parts per billion based on the sensor and the Department of Health's levels established in the safety plan, figure out how much risk is presented to the community at those levels. Here's an example calculation. Remember we talked about benzene cancer risk from the HHRA, 1 in 4.3 million. This was due to a 600 part per trillion level of benzene at the sensors around the waste beds. We have two scalings for cancer risk. One is, instead of 1,825 days exposure, we're going to look at the 251 for the next 2 years. Since there's a shorter duration of exposure, this actually lowers the cancer risk or raises the number, meaning the number will be bigger than 1 in 4.3 million. Unfortunately, we have to lower the number now because instead of 600 parts per trillion, we're now looking at 50 parts per billion as the minimum level that the sensor can detect. By going through this math, we find that at the lowest level the sensor can detect at, the risk to the community is 1 in 370,000 for cancer from inhalation of benzene. Following through these calculations for the other chemicals that are currently in the waste bed, remember these are the same chemicals they'll be pumping up in the sediment, but they are currently there based on the 2000 findings from the DEC. If we go through and calculate the cancer and the non-cancer risk levels for the minimum detectable limit of the current sensor and the notification and action levels established by the Department of Health for the next 2 years of operation, we find that there is significant cancer risk at the notification and action levels established by the Department of Health, greater than 1 in 10,000, and significant risk from non-cancerous effects. You can see here several hazard quotients that are over 1. Just to give you an example of how much risk is there, if you refer back to the Onondaga Lake record of decision, this is the whole reason we're cleaning the lake up for health effects. The assumption is that people eating fish will develop cancer and non-cancerous issues, and this is the level of risk that was identified in the record of decision. You'll see here it was broken up by age group, but in general the cancer risk is 1 in the thousands level, and the hazard quotients are somewhere between 16 and 26. We copy our table over from the previous page. You'll notice that the detector capabilities and the Department of Health limits set for the next 2 years introduce as much or even more risk than is currently in the lake from eating fish. Overall, the protection of human health will not be achieved under the current plan. So we have a problem with the current sensors, especially over the next 2 years for the community. The solution is very simple. The EPA has a long-established procedure for monitoring chemicals, volatile organic compounds at lower levels than the sensor can. Actually uses evacuated bottles that collect air samples and go to a certified lab. This is published. What we're suggesting is prior to any activity on the SCA, that the EPA DEC Honeywell initiate canister sampling per this procedure, TO-14A, and establish a baseline. We feel the Department of Health should reestablish lower notification and action levels to bring the overall risk to the community down. We're suggesting that notification levels should lie in the middle of the acceptable range, 1 in 100,000 for cancer, hazard quotients around 0.5, and an action level should be established that's equivalent to 1 in 10,000 risk of cancer and a hazard quotient of 1. This table at the bottom has calculated out the proposed notification and action levels for the volatile organics that are currently in the waste beds prior to pumping sediment. You'll notice that these levels are much lower than what the Department of Health has now. For example, benzene notification should be around 21 parts per billion, and the action level should be around 42 parts per billion. Thank you.